Okay, this is absolutely our last video for 2.2, and it's just doing this last problem here, where again we're being asked to just sketch a reasonable graph of the function. Looking at the function right here, and notice a few things. Number one, that it's an odd degree function, and that the lead coefficient a is greater than 1. It's a is greater than 0, it's 1. So odd degree and a is greater than 0. So that tells us, that information tells us that as x heads towards infinity, then f of x is going to also head towards infinity. So as x increases, the y values are going to increase. Right? And then as x heads towards negative infinity, f of x is going to head towards negative infinity, meaning that as these x values get smaller and smaller, then my y values are going to get smaller and smaller. So it's going to be heading down here, it's going to be heading up here. Okay, but that's... Now we need to factor, in this case of this equation, not the easiest to factor. Best way to do it is by grouping. So f of x equals, I'm going to go x cubed times x squared minus 4. So that's this first group right here. And then I'm going to go plus, and I'm going to factor out 8. That gives me x squared minus 4. That's this second part here. And of course, by doing that, I have these two factors are the same. So f of x equals x cubed plus 8 and x squared minus 4. All right, so that's factoring. Now I'm going to set it equal to 0. Okay. There's a rule that you probably don't remember from Algebra 2, but it says if you have a cubed plus b cubed, a way to factor that's going to equal a plus b, and then a squared minus ab plus b squared. Okay, so why does that matter? Well, if we go back up here, another way to write x cubed plus 8 is x cubed plus 2 cubed. Right, x squared minus 4x. So if we do that, then we can use this rule right here to rewrite this factor. So that's going to be x equals x plus 2, x squared minus 2x plus 4. And then I have this x squared minus 4. Now, if you were to take this equation here and set it equal to 0 and try to solve for it, you're going to wind up with a negative root, which we can't have. So this is what we call an imaginary solution. So we're going to basically just ignore that for now. We're not even going to worry about it. So we're going to say 0 equals x plus 2 and times x squared minus 4. So this gives us x plus 2 equals 0, x equals negative 2, and that's right here. And then here I have x squared minus 4 equals 0, x squared equals 4, x equals positive negative 2. So my zeros are going to be negative 2 and 0, 2 and 0, and I have another negative 2, 0. So technically I have, this is a multiplicity of 2, right? So negative 2, 0, multiplicity of 2. And then my other one is 2, 0. So let's put those points in here. This is negative 2, 0. Which has a multiplicity of 2, it means that it's going to be tangent, it's going to be bouncing off of that. And then my other point was 2, 0 here, and it's has a multiplicity of 1, so I know it's going to be going through here. All right. And we need to figure out what's going on between these zeros here. So I'm going to pick out some points. I'm going to pick out f of 0. Let's go ahead and go f of 0. And this is kind of nice because this will also give us our y-intercept. So tell us where it's intersecting the y-axis. So this would be 0 to the 5th power minus 4 times, let's write it down here. We're just taking 0 and we're plugging into our equation, right? So we have 0 to the 5th power minus 4 times 0 cubed plus 8 times 0 squared minus 32. Well, these are all, that's 0, 0, 0, so f of 0 equals negative 32. So I come down here, I'm just going to write it here. Don't worry about the scaling of it. So this is going to be 0 and negative 32. So I know it's way down here. And so it kind of helps me with what my graph's going to look like. Since this negative, should I look for another one? Oh, yeah, let's look at f of 1. Okay, oops. Just really quickly, f of 1. Okay, and I plug that into my original equation, so I have 1 to the 5th power minus 4, 1 to the 3rd, and plus 8, 1 squared, plus 32. So I might want to check that just to see, and if you do, and you do the math on it, it's negative 27. So it's up here, right? So I know it's heading back up towards this line. So that's good. It tells me this is coming down from here, gets to this point, and then the value increases. Now remember, when I get to 2, 0, that had a multiplicity of 1, so it's odd, so it's going to head up. And since my ending, I know that my ending behavior is for it to just head off towards infinity, and it's going to cross through there. Over here at negative 2, 0, that had a multiplicity of 2, so I know when it hits the x-axis, it's going to hit it and bounce off it. And then again, because this was an odd function, we know that as x heads towards negative infinity, f of x is also heading towards negative infinity. So it's heading off that way. So that's a reasonable graph.